Wow, lots of great talks today. I feel really honored to be on the stage with smart people. I'm going to, instead of talking about, smart stuff, I made a thing, and I'm going to talk about that. I'm from Texas. So do I have any fellow Texans here? Hot damn. All right. Okay. So I'm Barrett Clark, and I'm not very creative. You can find me at Twitter or GitHub at Barrett Clark. I've been a Rubyist for about 5 years. A long time web developer. I'm a recovering Perler. Long time. But I've been a Rubyist for 5 years or so, and I'm more of a polyglot nowadays, but I prefer Ruby where it makes sense. And I work for Sabre Labs, which is part of Sabre. Does anybody know Sabre? Okay, fantastic. If you've heard of a little website called Travelocity, that's our biggest consumer-facing brand, but we are a global distribution system, so if you have booked air travel or a hotel in North America, chances are that inventory went through our infrastructure. I don't mess with any of that stuff. I work for Sabre Labs, where we experiment with technology and ideas and business models that might or might not make an impact in the near future in the travel industry. So that's what's so great about me. Okay, so this project began as an Android NFC near-field communication experiment. Like I said, we mess around, we experiment. Specifically, that wristband that you see there on the far left, we were thinking about how can we make the travel process better? How can we make going through the airport suck less? And we thought, well, maybe we could have tap-in points or do all kinds of cool stuff. So we came up with a big map. We had a big discussion. We came up with a lexicon to discover what are all the different stages and points during the travel process. And none of that stuff is actually important. But it gives you an idea of where we were going and why we had the wristband or the tap-in points or the biometric sensor and all that stuff. But really what we wanted to do was answer a few questions. How long is it going to take me to get through this security line? Really? When do I need to leave my house to get to the airport so that I don't miss my flight? But from a business perspective, more importantly, the gate agent needs to know, do I need to hold this flight for anyone? You may not realize this, but it costs the airlines money. They pay fees if they are late pushing off from the gate. And so they're not going to hold the flight for just anybody. They're not going to hold it for me. But if they know that they have somebody who has status, and they know that that person is in the building, and they know that that person has made it through security, and it's probably just minutes away, then there's a pretty good chance that they're going to hold the flight for that person. The gate agents are really, really good at maximizing the efficiency and the effectiveness of that flight, and they're really good at their job and getting people where they need to be. And in the airline industry, status is everything. Status is everything. But then iOS 7 was announced, and where we thought before that maybe NFC was maybe going to be okay, maybe NFC was a thing, it was really, really clear that from Apple's perspective, NFC is not a thing, and Bluetooth is the future, Bluetooth low energy specifically, and so we pivoted. Okay, so to answer those questions, we need to know, where are you? Where am I? And location in general is pretty easy, but indoor location is a different animal. So geolocation, it's accurate within a few feet. It's really easy to store and query. Postgres with the PostGIS extension, fantastic. I've heard that you can do it with MySQL, but why would you want to? You've got Postgres. So it's easy to store, easy to query. It's pretty easy to set up. You can roll it, from source. You can use any of the major package managers, Homebrew, apt, Yum. And it's not difficult to set it up on a server. You can host it on Heroku with little pain. You don't get to use the free database to do the PostGIS stuff. And you have to play with build packs. But still, it's not hard to set up and host. Or you can just use the Postgres.app from Heroku also, and it's already got PostGIS baked into it. And the way your phone knows where am I is it takes a combination of GPS, which is from satellites, Wi-Fi, which is known access points. The Wi-Fi has a MAC address, and if that MAC address is known by your carrier, whether it's the Google or AT&T or whoever, then it knows where that access point is, and cellular towers. So that's geolocation. Indoor location, satellite's probably not visible, so it's going off those access points. And the third axis, the Z axis, elevation, is important. We had a situation recently where we were at SFO, baggage claim, which is the second level, and we whipped out our phone to pull up an Uber so we could get to the hotel. And a few minutes later, he calls us, "Hey, where are y'all?" I'm from Texas. "Hey, where are y'all? We just got our bags, we're baggage claim." Well, no, you're not. So he was at the first level, which is where Uber told him to go, latitude and longitude. But we weren't there because we were on the second level. So it's not where in the world am I, it's where in the building am I. That's indoor location. And a fun fact, Android can get more information from access points that it doesn't know anything about, has never connected to. Your iPhone is going to be a little more restrictive. So the point of all that is that indoor location is tricky. It's not the location of the access point that matters. It's your proximity. Okay, cool. So that's enough background. I made a thing. Let's talk about the specifics of that thing. And we'll start with the hardware. But first, let's be clear, what are we talking about? So the latest version of the Bluetooth spec is 4.1. Bluetooth Low Energy is a subset of the 4.0 spec. And iBeacon is nothing more than an implementation of BLE. There's no magic. Doesn't do anything really cool. It's just an implementation. Okay, cool. So here are some of the beacons that I made. The top thing there is a Raspberry Pi with a BLE 4.0 dongle USB thingy hung off of it. The Raspberry Pi is way cool. It's a lot of fun to play with, and I recommend it. I think it uses a version of the Debian distribution. And you can, it's a really wicked cheap Linux computer. You can plug a monitor into it, but generally it runs headless. I set this up using a blog post that I found from Radius, believe it or not. Chris here. And it was really easy to set up, and you do an initd script, so when it fires up, you've got your BlueZ all configured, and it knows all the things that it needs to know, and it just works. Those three rocks there are Estimote beacons. This is an Estimote beacon. When they shipped, they all three broadcast on a different channel, and I didn't like that. They said that you can't change that, but I did. You can. So now they work the way I want them to. And then that little bitty red board there is also pretty cool. That is, it is red, believe me. That is a Red Bear BLE Mini, and it is really tiny. You can solder a little bitty watch battery to it, but I chose to not do that. And it takes an Arduino BLE Fermata sketch that you put on the board, and then you can configure it. So I got to play with hardware. I'm a software guy, and I got to play with hardware, and that was fun. Okay, so we got our beacons, and now we need to interact with them. I wrote both iPhone and Android apps to do this, but today we're going to talk specifically about the iPhone implementation, and it was more fun. So Apple stuck, for some reason, the iBeacon implementation in core location, and that sort of makes sense in some ways, and it's really awkward in other ways. You'll see why. So let's understand core location first. Does anybody here do Xcode, Objective-C? Okay, I'm sorry. So first, you just say, okay, I want to configure some things. I want it to be the best accuracy, because why not? Although do know more accurate is more expensive. You get lots of readings, and they all have different accuracy levels, and so your phone has to work harder to get a better reading. And you can set, if you want to monitor movement, you can set what the distance threshold is. And then you say, hey, start updating locations. There'll be a delegate method that gets called when it gets the locations, called did update locations, boom. And then you can do cool things with that location, like know where you are, or post it to a service and then understand other things about it. Now, the CL Beacon edition, well, first let's understand the iBeacon spec, right? So there are 3 pieces of information. You have a proximity UUID, and that's essentially a channel. That is, the beacon is going to broadcast on this UUID, and you listen for this UUID. You can listen for a lot of them. I think it makes more sense personally to just say this is my channel. And then there's a major number and a minor number. The major number is your group of beacons. The documentation specifically says it's a group. So you can think of that as a building, a terminal, a floor in a shopping mall maybe. It's just a group. And then the minor is the specific beacon within that group. So it would be the gate or a hotel room or the specific counter in the department store. And of course, there's profit, right? Okay, so core location, single-step process. I want to get updates. I get updates. It's pretty easy. Beacons are a 2-step process. First, you look for the beacons, and that's the monitoring. So you saw there's the UUID, the proximity UUID, and then you can specify the same method could have different signatures in Objective-C. So that init with proximity UUID, you don't have to specify a major number. You can. You don't have to specify a minor number. You can. So you can be as specific as you want. And then you say, okay, cool. I want to start monitoring for these things now. So you listen for those things on the channel, and when it sees one, it determines state. Did determine state. So once it knows that they're out there, then it starts figuring out, what does that mean? How close are they? What do I have? And when it stops seeing them, then it stops ranging. So you get back an array of the beacons, and they're sorted in order by proximity and then accuracy. The proximity constants are unknown, immediate, which is on top, near, which is within 2 or 3 meters probably, and far, which is Bluetooth BLE goes to a range of about 50 meters. So the closest one may be an invalid reading because it sorts to the top of the list, which is unfortunate, but that's how it does. So you have to be smart about how you look through that array, and then you can take the first one that is the nearest one, or you can triangulate and then figure out where you are. Okay, that was a lot of Objective-C. This is a Ruby conference, so let's move on. Okay, so we know where you are and what you're near, and I wrote a Rails backend to figure out what that means. Well, I actually broke it out into 2 different services, and we'll talk about why. So there's a reading collection server, and it is write-heavy, super dumb, doesn't do any enrichment, just store as fast as possible, return back a reading ID, and then I publish that reading for anybody else who cares to listen. And I used MQTT. We'll talk more about that here in a second. Simple services can be simple. We don't have to make really super complicated things. That's the entirety of the reading collection service. And you can see it does 2 things. One of them isn't actually even fully necessary. It creates the reading. That's the method that the phone posts to. It gets back the reading ID. And then there's a show method, so you can, from the command line using curl, ask, what is this? What is this thing? What is this reading? And it also provides a nice backdoor in case the pub sub failed. It never did, unless I messed it up. But it was nice to have the curl functionality. Curl is your friend. So this is the model, and you can see here I've got a couple of different validations based on whether it was a GPS reading or it was a beacon reading. And I cached it and then published it. Boom. All there was to it. There was a really simple Rails app. And then I had to collect the location server to help resolve what that stuff meant. And I broke it out. Initially, they were all one thing, and I broke it out because you don't always need to know what that reading means. And we wanted to be able to scale the two things separately, and I wanted to play with MQTT, which is a really simple pub/sub thing, and it's much easier to deal with than AMQP and RabbitMQ, and it works really, really well. So the location server uses PostGIS. It subscribes to that reading topic. It has that REST call in case the pub/sub failed, but it never did. And then it's able to tell that native app what that reading means. So if you're at a gate, let's just say you're at a gate. That gate is in a terminal. That terminal is in an airport. And that airport is DFW International. So you get 4 things back. And then the phone figures out what that means based on where you've been or whatever. But it may not need to know that for every reading, so they're separated. Okay, here's some examples of PostGIS in use. And if you've never used PostGIS, you see here, it looks kind of strange. I've used both the RGO helpers. The active record PostGIS adapter sits on top of the RGO gem. And I use PostGIS directly. I've used PostGIS for a few years. I'm really comfortable with it. I like it a lot. I'm used to writing wall of SQL queries that do all kinds of crazy stuff. And so I typically just hit PostGIS directly with the raw SQL. But RGO does have some nice helpers that I'm starting to actually explore. So if you don't know GIS stuff, I'll give you a little introduction here. That ST contains that you see at the top there, that says, is this point within this geofence? The ST intersect says, do these two geofences overlap? So you're able to say, this reading, where is this reading? Or, I don't know why the other one does ST intersects. I have to go back and look at that. But anyways, so that was how I was able to tell the phone then where you were given the coordinates. This is the initializer for MQTT. You can see it's really easy. And it just listens on that topic. No big deal there. Okay, so we've got the hardware, we've got the phones, we've got the Rails app. Where's the airport? So with all that stuff, we're able to do something like this, where we're able to say, okay, we know where you are, where you've been, and here's some helpful information for you on your journey through the airport. Once you get past security, let's say, we would say the gate is to your right, 200 feet, and there are 2 bathrooms between you and the gate. Here's the Android version. Woo! I am doing programming. Yeah, they have all these layouts, and none of them are exactly what you want or work. But more importantly, remember, we're really interested in like the business, because we are a business and we want to make money. So the gate agent can know where all the people are. And they know here I've boarded, so the flight's good to go clearly. But they're able to see then for all the people, and then they would know, again, status is everything. Is this flight in trouble? And we added here a stage that we didn't put on the phone for at the gate counter, so that the agent could know, as people approach them, who are they? Do they need, they could give them personalized service. Status is everything. Maybe they know somebody's in the line, but they're kind of in the back, so they can get pulled forward or whatever. So we're able to, using proximity, we're able to help you and help the company. So prototyping the airport. It doesn't have to be an airport, but that's what this was. Geolocation for where in the world am I? Have I made it to the airport? Proximity, iBeacon, for where specifically inside the building am I? And then a Rails backend to decipher what does it all mean. But most importantly, it can answer all the questions. I'm Barrett Clark, and I work at Sabre Labs.